Hi, I'm Elizabeth with Logic Walk. In the last lesson, we watched computer A send the message Hi B and saw it appear on computer B's display. In this lesson, we'll examine that same program step by step, starting with how computer A prepares the data, how the network device transfers it, and then how computer B receives and prints it. Let's take a closer look. Let's look at what the simulator shows at time 8 for computer A, network A, and computer B. At time 8, computer A is at program counter 8. By this point, it has stored the message, the ASCII values for Hi B, into its network buffer, memory cells 50 through 54. Memory cell 66 holds 5, the data size. Memory cell 67 holds 66, the ASCII code for B, telling us the destination is computer B. Memory cell 68 is on, signaling to network A that the message is ready to send. Network A hasn't copied any data yet, so the number sent is 0. Computer B is idle at program counter 0, waiting to be interrupted by the network device. Since number sent is less than the data size, the transfer continues until those two values are the same. At time 9, computer A's state hasn't changed. Network A increases number sent to 1, and computer B receives its first value, 72, the ASCII value for capital H in memory cell 50. Because number sent is still less than the data size, the process keeps going, sending each remaining character until number sent equals the data size. At time 13, computer A's state is unchanged. Network A's number sent has reached 5. Computer B is still at program counter 0 and has just received the final value, 33, the ASCII code for the exclamation point in memory cell 54. Now that number sent equals the data size, network A has finished transferring all the data. At time 14, memory cell 68 in computer A has been reset by network A, and all other cells remain the same. Network A resets number sent to 0. Computer B is still at program counter 0, but interrupt cell 2 is now on, taking it out of its idle state. Memory cell 66 holds 5, the data size of the message, and memory cell 67 holds 65, the ASCII value for A, representing the ID of the sender. At time 15, computer A and network A remain the same. On computer B, interrupt cell 2 has switched off. The program counter has jumped to instruction 3, as directed by the interrupt table, and memory cell 4 now holds 0, the saved PC value from before the interrupt. From this point forward, computer B enters its loop to move the received characters into the display buffer and print the message, following the same display process we first explored back in chapter 2. Now let's look at a more general scenario. Suppose at some time t, the state of computer X is memory cell number 50 plus count, its buffer cells, holds some value we'll call val. Memory cell 66 holds the total data size. Memory cell 67 holds y, the destination computer's identifier. And memory cell 68 is on, signaling the network device that data is ready to be transferred. The network device's number sent currently holds some value we'll call count. If count is less than size, then at time t plus 1, computer X's state stays the same. The network device increments number sent to count plus 1. Computer Y's network buffer cells 50 plus count now holds the value val, copied from computer X. Later at time u, computer X's state is still unchanged. The network device's number sent now equals size, meaning it's finished transferring all data. Then at the next time u plus 1, cell 68 in computer X is turned off by the network device. The network device resets number sent to 0. Computer Y's program counter is at some location PC. Memory cell 66 on computer Y holds size, the data size of the received message. And memory cell 67 contains X, the ID of the sender, and interrupt cell 2 is turned on. At the following time, U plus 2, computer X and the network device remain unchanged. On computer Y, interrupt cell 2 resets to 0. Memory cell 4 now holds PC, the location of computer Y before the interrupt, and the current PC value is now updated to 3. That wraps up this lesson. In our next and final lesson of Chapter 5, we will review network devices in the real world.